The last thing that we're going to do in lesson 3 is very similar to what we just did, except instead of using sum and difference identities, we're going to use double angle identities. So it'll say something like, given that tan theta equals -3/4 and theta is in quadrant 2, find each of the following. So sine 2 theta, cos 2 theta, tan 2 theta, and then determine which quadrant 2 theta lies in. Now I put a process here, but it's very similar to what we just did, and we didn't have a process there. So first thing we're going to do is figure out where to draw theta. So they're telling me that theta is in quadrant 2, so I'm going to draw it over here. And they're telling me that the value of tan theta is -3/4. Now that negative is either up top or down low, and the only way you're going to determine it is looking at your picture. So the 3 is my opposite or my y value. The 4 is my adjacent or my x value. So which one's negative? Well, it's the x. Okay, then we have to determine the third side, which in this case is my hypotenuse. So I'm going to say r squared equals 3 squared plus -4 squared, which is going to give me 9 plus 16, which is 25, which tells me that r is the square root of 25. I don't need plus or minus because radius can never be negative, so it's going to be 5. And now using this, we're going to evaluate sine 2 theta, cos 2 theta, and tan 2 theta. So let's start with sine 2 theta. Now hopefully you've done enough identities that you have that one memorized. So sine 2 theta is 2 sine theta cos theta. If anyone's unsure, right, we go to our formula sheet, double angle identities. Sine 2x is 2 sine x cos x. Okay, and then we know that sine theta would be opposite over hypotenuse, and cos theta would be adjacent over hypotenuse. It's funny how I've reverted to hypotenuse and adjacent and opposite. I was really into x, y's, and r's for a long time. And then we're just going to simplify. So I like to write that this is 2 over 1 to remind me that I'm going to multiply across. So 2 times 3 times -4 gives me 6 times -4, which is -24, over 1 times 5, which is 25. And that's it. That's sine 2 theta. So the next thing we're going to do is we're going to do cos 2 theta. Now cos 2 theta, if you remember, we actually have choice. And so we get to choose whether we want to use cos squared x minus sine squared x, 1 minus 2 sine squared x, or 2 cos squared x minus 1. Usually if I'm an in-person class, I get like a third of the class to do the first one, a third of the class to do the second one, and a third to do the third, because then it proves that we all end up in the same place. This is a video and I feel like you're going to get bored if I do all of them, so let's just pick the first one. So let's do cos squared theta minus sine squared theta, and I always just double check that I'm not messing that up. Perfect. Again, not one that we use very often. So in for cos theta, I'm going to put in that -4 over 5, right, adjacent or hypotenuse, or x over r, and then it's squared. Minus, I'm going to put in the sine of theta, which is that opposite over hypotenuse, or 3 over 5 squared. This gives us 16 over 25 minus 9 over 25, which gives you a common denominator, and my numerator would be 16 minus 9, which is 7. I say questioningly. I hope nobody's yelling at the screen. I always get nervous making videos and I'm going to screw up my mental math. I think we're good. All right, and again, if you had done it as any of the other two, maybe test it out now if you don't believe me, but you can try the other two and you will get this exact same answer. The last thing we are going to do, well, second last thing we're going to do is C, which is tan of 2 theta. And now for this one, you actually get a choice. You can use the tan 2 theta identity and do 2 tan x minus 1, or divided by 1 minus tan squared x. Or don't forget that tan 2x is equal to sine 2x divided by cos 2x. So we could just do sine 2 theta over cos 2 theta, and we already solved for them. So sine 2 theta we found was -24 over 25. I like it when my 4's turned into 9's. Cos 2 theta is 7 over 25, and then we just do the division. -24 over 25 divided by 7 over 25 would give me -24 over 25 times 25 over 7, Then I get to simplify, which I always love using a different color. And then it gets me, multiplying across, negative 24 over 7. And again, if you don't believe me, feel free to look at your tan 2 theta identity, plug it into there, and do that whole compound fraction mess. This is much easier. All right, the last thing we're going to do is D, which is kind of a weird one. So we gave theta. Tan theta is in quadrant 2. But all of these wanted to know 2 theta. So if you double angle theta, where will that angle be? Well, if angle theta was like 91 degrees, then double that would be 182, which would be in quadrant 3. If angle theta was something like 150 degrees, which is still in quadrant 2, if we double that, we're at 300 degrees. So the question is, are we in quadrant 3 or quadrant 4? Well, how can we tell? We're going to look at the cast rule. First thing we look at is that my sine 2 theta is negative, which tells me that it has to be in quadrant 3 or quadrant 4. Well, that doesn't help me. I already knew that. So let's look at the next piece of the puzzle. We know that cos 2 theta is positive. So that tells us that it has to be in quadrant 4 or quadrant 1. Well, we already know it can't be in quadrant 1. Right? Because it's double angle theta, but let's pretend we didn't know that. Let's do the last piece of the puzzle. And we look at, so let's go to a different color. And we look at tan 2 theta. Now tan 2 theta came out negative, which means it has to be in quadrant 4 or quadrant 2. So the big winner is going to be quadrant 4. And so 2 theta is in quadrant 4. And you'll notice at no point did I ask you to solve for theta, right? I mean, I guess we could have up here. We could have done inverse tan of negative 3/4 to determine what angle theta is. And then we could have figured out what double that is, and so what quadrant it would be in. But that's no fun. I wouldn't get to use colored circles. Yeah, so that is evaluating using double angle identities.